Hi everyone. So let's do today's daily Lead Code challenge question. I also have not looked at this question before. Let's read it. 1894, find the student that will replace the chalk. Okay. There are n students in a class numbered from 0 to n minus 1. The teacher will give each student a problem starting with the student number 0, then the student number 1, and so on until the teacher reaches the student number n minus 1. After that, the teacher will restart the process starting with the student number 0 again. You are given a 0 indexed integer array chalk and an integer k. There are initially k pieces of chalk. When the student number I is given a problem to solve, they will uh, there are initially k pieces of chalk. When the student number I is given a problem to solve, they will use chalk I pieces of chalk to solve that problem. When the student number I is given a problem to solve, they will use chalk I pieces of chalk to solve that problem. However, if the current number of chalk pieces is strictly less than chalk I, then the student number I will be asked to replace the chalk. Still streaming, right? Okay. Return the index of the student that will replace the chalk pieces. Okay. So let's look at the example. Chalk 0 and 1, chalk 5, 1, 5, k equals 22. So what does k mean? K means k pieces of chalk. So there are 22 pieces of chalk, and um, and 5. So student number 0 will use 5 pieces of chalk, right? And then student number 1 will use 1 chalk, student number 2 will use 5 chalk, student number 0 will use 5 chalk, 1 will use 1 chalk, 2 will use 5 chalk. So when 2 uses it, then student number 0 does not have enough chalk, so they will have to replace it. Okay. Okay, got it. So because there are 22 number of pieces, so first of all 22 minus 5 equals to how many left? 17, and then 16 will be left, then 11, then 6, then 5, then 0. No more chalk left. Since no more chalk left, so 0 needs 5 chalk. So it will, yeah, it makes sense. So let's look at another example. Chalk C, k equals 25. So there is 3, 4, 1, and 2, and 25, right? So I need 3, 4, 1, and 2. So the 3, 4, 1, and 2. What is the sum? 4, 5, 6, 7, 8, 19. So it means that first round, they can go first round, right? So when they go first round, then it will be 4, 5, 6, 7, 8, 19. Then they will go first round, they will go second round. It will be 20. First, second, third, fourth. So when they go second round, then it will be 20. Now only 5 chalk will be left. So it will be like 5 chalk is left, and I have to do this. So then since this 5 minus 3 is equal to 2, so this should replace, right? Second, first student. Yeah, I think I can, first of all I just need to do 25, k modulus of total sum 10, because that will give me that will give me because that will give me the last repetition, because if I have like 1000, then I will repeat and repeat and repeat, right? So what is the last repetition? That will give me that, the only modulus will give me that. So suppose if k was just 4, then in that case it would have been 4 percentage 10 would have been just 4 only, and then I could have just have like gone O of n, and then I could have done that, yeah. So first, number 1 is first find modulus to get number of chalks for last repetition, and then for last repetition I can just subtract. So this is O of n, so this will take O of 1 time, but this will, and because I am thinking of subtracting, so it will just take keep subtracting, so it will take O of 1 n time. Yeah, so modulus will keep that, right? 4 5 6 7 8 9 10. Suppose k was like 70 or 11, remain. That would have been the case. So first of all, I need to find sum. So constant sum will be equal to chalk dot sums or something. Okay, I need to write that. This is just the pseudocode, and then let last repetition number, it would have been sum, it would have been k percentage of sum kind of thing. And then after I get last repetition, I need to go through the chalk now. I is equal to 0, I is less than chalk dot length and I minus I plus plus, and then constant current will be equal to chalk I, and I just need to check if current I if it is greater than current or not. If it is greater than current, then great, it means that that student will use it. If it is not greater, then it means that I have to return that value. Suppose k is equal to just 10 only, then it would have been 10% is 10 0, so I'd only have 0 chalk left, so it would be I only. Yeah, I think this would work. So how can I get the sum? Math dot sum something for constant. That is the sum and k modulus last repetition number. Oh no, 71 of 72 test case passed, just one test case failed. Wow, looks like I some edge case. So chalk dot length is equal to n, and n starts from 1 to 10 to the power 5. And chalk I chalk that length. So it can go up from 1 to 10 to the power 5. Okay, and chalk I, it can go from 1 to 10 to the power 5, and k can go from 1 to 10 to the power 9. Okay. So why did this fail? Summation. Oh, not solution. I don't want to look at the solution. Okay. Submit. When submitting, why did this test case pass fail? So output is 999, but expected is 999. Output is 998. From 0 to 998. Interesting. So what is the sum in this case? I'll just copy, okay, and then I'll just add it in the test case. And then I also have to add k, right? So let's add k, and let's console that log sum. So sum is 1000. Okay, sum is 1000. Sum is 1000. So what is the last repetition number then? Last repetition number is 999. So I will have 999 chalks left. Okay. Yeah, actually answer should have been 999, right? Because looks like my last repetition number, it will be 999. So, and it looks like everything is 1 only. Since I have a 999 chalk, so it will be like, okay, suppose if I just add 2, 1 and 2, okay, and 1, 2 and 3. So their length is 3, and I only have 2 chalks left. Then my answer would have been 0, 1. My answer would have been if I had 2 chalks left, then my answer would have been, so first 1 will be left, and then 1 will be left, and then 1 will be, and then 0. Actually it should be greater than or equal to, right? Because it can also be greater, it can also be equal. Yeah. Wow, I missed that equals to here. Wait, it was also easy question. Prefix sum, O of n and O of 1, mine also the same. Binary search, wow, that is why I should have done binary search, because I'm doing time complexity is O of n here. So if I had done binary search, then it would have O of log n. So that is the trick here. And how could I do binary? How could I have done binary search here? So with the last repetition number, I could just have, gone until the middle and found that found the sum, I guess. So is it the left or is it the right? I should have known that. I could have known that, right? Oh, time complexity is still O of n. Space complexity is O of n. Wow. looks like this is easier. Sum is equal to 0. This is sum. If sum is greater than k, then break. Find the modulo. And k is equal to k minus 0, return 0. This is an easy question actually. Yeah, this is easy, true. Optimal solution with, even if its basic application is not trivial, combining two algorithms is not immediately obvious to most beginners, would be aim towards. If you find a easy, but how is this optimal? Like this is optimal solution, right? O of n and O of 1, not this. Why did this point? Why is this person saying this is the solution? This is the optimal solution. That's what I'm saying. Okay. What is prefix sum? Did I do prefix sum? Array of chalk of n elements representing the number of chalks used by each student. Observe that okay, anyway, thank you everyone.